Okay, first topic in Module 6, I think you're going to find pretty easy for yourself. Solving an equation written in factored form. So you have for sure done a lot of this in past courses. It should come pretty easily to you. In fact, you might have even tested out of it in the knowledge check. So in an exam, and you might just need a little refresher. That's okay. I don't mean to make you feel bad if you don't know it, but it's a pretty easy one to get for you, I think. So like if you have 3 minus z times 4z minus 9 equals 0. And you may remember from Algebra 2 the zero product property, which means if we are multiplying things together and getting 0, then at least one of those things has to be 0. Okay, so all we do is take each factor and set it equal to 0 and solve. So if 3 minus z could be the one that's 0, then that would mean z equals 3. Or 4z minus 9 equals 0, which means 4z equals 9, which means z is 9/4. Okay, so you would just write down your two answers, z equals 3 or z equals 9/4 are the two possible answers to this. Okay, I can do another one real quick if you need it. If we have something like 4y minus 7 times 5 plus y equals 0. So again, just take your first factor, set it equal to 0. So y would be 7/4. Second factor, set it equal to 0. Y would be -5. Okay, that's a nice one. All right, we're going to move on to the next topic right away then. The next one is going to be finding the roots of a quadratic equation. Quadratic, remember, just means that there's an x squared. Of the form ax squared plus bx equals 0. Okay, so you just have to factor it first, and it's going to be a GCF that has x in it. Okay, so if you have ax squared plus bx equals 0, you can always factor out an x. Okay, and then you can solve for x equals 0 or ax plus b equals 0. And there might be a number in front of that x if a and b have a common factor, or it might just be an x. So we'll do a quick little example here on this one. If we have 6y squared minus 30y equals 0, we can factor out the y, just like I showed up here how we can factor out the x, but from the 6 and the 30, we can also factor out a 6. And what's nice about this is that even if you miss that, you'll still get the right answer. Okay, so we would have 6y equals 0, which would mean y equals 0, or y minus 5 equals 0, which would mean y equals 5. So there's your two answers. And like I was saying, if you missed that 6 can factor out of there and you just did the y, you get the same thing. Because when you solve for that, you get that factor of 6 out of there anyways. Okay, and you get the same two answers. We can do another example for that one. I'll just do it to the side over here. If we have something like 6x squared minus 12x equals 0. So we'd factor out a 6x and set them both equal to 0. So if 6x equals 0, then x is 0. If x minus 2 equals 0, then x is 2. And you get your two answers. Okay. All right, moving quickly here through some of these. Next one is finding the roots of a quadratic equation with leading coefficient 1. Okay, so this just goes back to your factoring, and honestly, you guys have been doing this since you were in Algebra 1 when you've learned how to factor. So you remember, you got to split that middle term, right? So like w squared plus 8w plus 7 equals 0. And if you remember, we'd have to multiply to equal 7, and we'd have to add to equal 8. So that's going to be 7 and 1. Okay, and so then you make your little box. Some of you caught on to this pattern pretty quickly, though, in algebra, that you really don't need the box for this one. But you can do your w squared, and you split that middle term into 7w and 1w because of these two numbers right here, and then the 7. Okay, so all you do is you split that 8w into 7w and 1w. Okay, and then remember you kind of factor out of the area model. So we can factor out of the first row a w, which means that this has to be a w, this would be a 7, this would be a 1, w plus 1, w plus 7. Okay, and again, like, we really didn't need that area model till we put a coefficient in front of it until it's not 1. We'd have a coefficient that's not 1. You can really just, once you have the 7 and the 1, it's going to be w plus 7 and w plus 1. Okay, don't forget that you have to solve it, though. Finding the roots, you're solving for when that would equal 0. So it'd be when w is negative 7 would make the first factor 0, or negative 1 would make the second factor 0. Okay, another example on that one. If we have y squared plus y minus 12 equals 0, so we need to multiply to be negative 12. So one will be positive, one will be negative with our numbers. And we need to add to get 1, okay? Which means they're going to have to be just one unit apart, with one of them positive and one of them negative. So we're going to have a positive 4 and negative 3. Okay, and like I showed you before, we can kind of bypass that area model if we want. It'll just be x plus 4, x minus 3. So x would be negative 4 or positive 3. Oops, and I switched from y's to x's, right? We used to always seeing these with y's. I'm sorry, with x's. So I'm just going to change my answer there. This should be a y. Okay. Moving right along to our next one, we're going to factor when it's not a coefficient of 1. So we're going to do finding roots of a quadratic equation with leading coefficient greater than 1. Okay, so now this one, you've seen this before too. It just takes a little bit more work. When I learned how to do this back in the olden days, it was just kind of a guess and check process. When I first learned that area model, probably like 10 years ago, it was kind of cool how the area model just always works. First of all, we need to make sure, this was the original problem. It needs to be set equal to 0. So we got to add that 8x to both sides. Okay. So make sure it must be set equal to 0. Okay. And now multiply to be 12. you take the first and the last term for the multiplying. Just before the first term was 1, so it didn't matter. So we only had to worry about the last term. Now we need to multiply together the first and the last, and we need to add to be 8. So we should have 6 and 2, correct? So that means that we split that 8x, that middle term, is going to be 6x plus 2x. Okay, so we make our area model. And we're going to have our 4x squared, 8, not 8x. 6x, 2x, and the 3. Okay, so again, when I look in that top row, I can there's a 4 and a 6, so I can factor out a 2. And there's an x squared and x, so I can factor out an x, which then would make this guy 2x. So when I multiply them together, I get 4x squared, which means this is 1, and this is 3. So I'll have 2x plus 3 times 2x plus 1 equals 0. And now I just solve them. 2x plus 3 equals 0. 2x equals negative 3, so x is negative 3 halves. 2x plus 1 equals 0. 2x is negative 1, so x is negative 1 half. There's my 2 answers. Okay, we'll do another one of those. We have 4v squared plus 5v equals 6. So again, your first step is to get that equal to 0. Okay, now we need to multiply to be negative 24. We have the positive 4 and the negative 6. And we're going to add to be 5. Okay, so that one might take you a little second to think about it. This is a terrible bracket. We'd have a positive 8 and a negative 3. Okay, so in our area model, we'll have the 4v squared, 8v, negative 3v, and negative 6. So top row, I can factor out a 4v, which would leave a v here, and a 2 here, and a negative 3 here. So 4v minus 3 times v plus 2 equals 0. So that would mean 4v equals 3, v equals 3/4, or the other factor, v is negative 2. Okay. All right. Number 5 already. Another one from Algebra 2. If you saved your interactive notebook from Algebra 2, that'd probably be really helpful. Writing a quadratic equation given the roots. So all the problems that we've just been doing have been finding the roots. So we're going to work backwards, and the leading coefficient. Okay, so an example on this guy is write the quadratic equation whose roots are negative 4 and 2, and whose leading coefficient is 2. Okay. So what we're going to do with this is, like I said, we're going to work backwards. We have the roots, x equals negative 4 and x equals 2, which means we have the factors, x plus 4 and x minus 2. Okay, you got to think about what you would add or subtract to those to get to 0, right? In our previous problem, if x plus 4 was a factor, then x equals negative 4 was a root. Okay, so then the equation would be x plus 4 times x minus 2, plus you got to have that coefficient out front. Okay, so there's your coefficient. And here's your factors. Okay, and then your last step is to expand that. So we would need to do x plus 4 times x minus 2. So we'd have x squared plus 2x minus 8. Okay, and then we can't forget our coefficient there. We have to multiply everything by 2. So we'd have 2x squared plus 4x minus 16, and remember that's all equal to 0. So we can do another one like that. You write a quadratic equation whose roots are -3 and 5, and the coefficient that they give you in the problem is 2. Okay, so again, if they give you those roots, then your factors are x plus 3 and x minus 5. So we're going to do 2, because of the coefficient, times our big area model, x plus 3, x minus 5. Okay, so x squared, negative 5x, 3x, negative 15. So we'll have 2 times x squared minus 2x minus 15. So 2x squared minus 4x minus 30 equals 0. All right, we are cruising along. Let me see if there's other ones that I want to do right away here. Well, I think I'm going to stop that video there because I think we got 5. Okay, so I'm going to stop for a second and we'll start the next video.